Hare Krishna everyone. So today I'm going to start with your divergence, that is the second lecture of our mathematical physics lecture series. Okay. So let's start with our divergence class. Okay. So basically divergence, as you can also say, that is in previous class I have discussed about the gradient. What does gradient means? Gradient always operates on a scalar and it gives a vector. Okay. Whereas your divergence, in case of divergence, what happens? It acts on a vector. Okay. It acts on a vector. Divergence always acts on a vector. But in case of gradient, your answer will be vector. But in case of divergence, as it is acted upon a vector and its result, but its answer is scalar. Okay. Hope you all are understanding what I am trying to say. So let's suppose let a vector is my x I cap, a y j cap, a z k cap. Okay. So divergence, how do we represent divergence? See, divergence we represent Nagla operator dot your A. So it will give rise to what is del I cap del y del x, sorry. Yes. I cap del y del x plus j cap del y del y. I am writing it in Cartesian coordinate because I have taken the vector in Cartesian coordinate. That is your I cap, j cap, k cap are the unit vectors. So I will write it like this: k cap del upon del j dot product with your a vector, that is your ax I cap. You all know what is dot product. No need to say about it. Okay. Ay j cap and az k cap. Okay. So you just do what? You just do dot product. So what you will get? Del ax upon del x plus del ay upon del y plus del az upon del z. Okay. This is what divergence look like. Okay. Make it a box for your convenient. Make it a box. Okay. Let me take another slide to understood you. That is geometrical interpretation of divergence. What do we mean by divergence and what does its physical significance? Okay, let me tell you something. That is, divergence tells us is divergence, that is del dot v. If I will write, tells us how much vectors spreads out vectors spreads out spreads out. Okay, from from point vector vector is known as solenoid solenoidal if my divergence of f is 0. So what does it means? See, if I am writing the divergence of a vector is 0, that means it is solenoidal. Solenoidal means it doesn't spread out. If I will say, let's suppose this is a vector field, okay, and it spreads out like this. It spreads out like this. You can say it has some divergence. Okay, we could say yes. So divergence basically means your how much the vector spreads out from a point. Okay, hopefully you all understood. Okay, let's proceed towards the divergence in two other coordinates, that is your spherical coordinate system and your cylindrical coordinate system. So first of all, we will write for spherical coordinate system. Spherical coordinate system. In case of spherical coordinate system, how do we write a vector? Remember, we have spherical coordinate system r, theta, and phi. Okay, so I will write it ar cap plus a theta cap plus a phi cap. Okay, I can write it like this. So divergence of a vector in spherical coordinate, I can represent it like this: 1 upon r square del y del r, sorry, del y del r, okay, del y del r square ar plus 1 upon r sin theta del upon del theta, that is sin theta a theta, and your last component, that is your 1 upon r sin theta del upon del phi a phi. You just remember it, okay? You just have to memorize it, okay? So this is in spherical. So what does in cylindrical? In cylindrical coordinate system, you have the coordinates, that is rho, phi, and z. Okay. So how do we write the divergence here? Okay. So I can write it like this: 1 upon rho del y del rho, rho a rho. A rho is the component along rho cap. Okay. Plus 1 upon rho del a phi upon del phi. Okay. Plus del az upon del z. Okay. It's simple. This one is cylindrical. Let me see how does the problem comes. Okay, if you have given, let me suppose a question is given like this. Example, we will see. The question is like this: a vector is given as your r cos theta r cap r sin theta theta cap plus r sin theta cos phi phi cap. Okay, a vector is given as this. You have to find out the divergence. Okay, first of all, you see the components. The components are here: r cos theta, a theta is your r sin theta, and a phi is your r sin theta cos phi. Okay, this is all. Remember the formula in spherical coordinate I have written as del dot a. This is spherical coordinate. Del dot a is 1 upon r square del upon del r. That is your, remember, AR is your r cos theta, and you have to multiply it with r square. R square AR is there. See, I have written here r square AR. Okay, you have to write it like this. Okay, so what it will become? It will become r square, r square into r cos theta, isn't it? Plus the second one is your 1 upon r sin theta. Okay, del upon del theta, that is your r sin square theta, that is a theta. See the formula. See the formula. Here I have written sin theta into a theta. Your a theta was r sin theta, so multiplied with sin theta, so it will become r sin square theta plus your 1 upon r sin theta del upon del phi into r sin theta cos phi, isn't it? See the third component, what was that? Yes, yes. See, the third component is simply 1 upon r sin theta into del by del phi into a phi. Okay, so it will become like this. So if you do the calculations, you will get 1 upon r square del upon del r of r cube cos theta. Cos theta is not the variable with r, so we can differentiate like this: 3 r square cos theta. I can write it like this: 1 upon r sin theta del upon del theta of r sin square theta. R coming out inside the bracket and your del theta, so it will become 2 sin theta cos theta. Okay, are you understanding, students? Yes, 1 upon r sin theta del upon del phi of r sin theta cos phi, getting r sin theta outside the bracket and differentiating with respect to phi, that is cos phi, so it will become minus sin phi. You know that is derivative of cos, it is minus sin, and derivative of sin, it is minus cos, only cos, positive. Okay, so what do you get? You get from here, if you calculate further, that is del dot A will become your 3 cos theta, 3 cos theta. See here, this, see what I have. 1 of r square getting cancelled, so you get 3 cos theta, and here r getting cancelled and sin theta getting cancelled with sin theta, so you get in the second you get 2 cos theta, and in the third r is getting cancelled, sin theta is getting cancelled, and you got only sin phi. Okay, so what do you get? 3 cos theta plus 2 cos theta 2 cos theta minus sin phi. Okay, this is all about. So final answer is your 5 cos theta minus sin phi. This one is the divergence. How do we calculate the divergence? Okay, in different coordinate system. If I have given you the vector that is in cylindrical coordinate system, similarly you have to put the formula for divergence in cylindrical coordinate system. Okay, this is all about your divergence. Okay, so sometimes questions also ask if you have given, let me give you some example. If a vector is given as your x I cap plus 2 j cap plus 3 k cap. Okay, you have given a vector is like this. You have to find out, find out the value of x if a vector is solenoidal. Okay, remember I have told you that a vector is only solenoidal if and only if it is its divergence is 0. So divergence 0 means your del dot f is 0. So I can write it del x upon del x plus del upon del y 2 plus del upon del z 3. Okay, see students, I have given these questions from my mind. So you see here I have to write it 2y and 3z. Let's suppose it is 3z. So what do you get on differentiating? You get del upon del y of 2z, del upon del z of del upon del z of 3z. Okay, is equal to 0. So you get from here, let's suppose this is x square. Okay, so del upon del x of x square. Okay, so you got from here 2x plus from here 2y is there, so you got 2 plus 3z is there, so you get 3 is equal to 0. So the value of x you got minus 5 by 2. This is the value of x. If the I have just given you an example. This is from my okay from my conceptions. Okay, it was not given in any book. Okay, I have just write it. How do we find the value of x if a vector is solenoidal? Okay, this is just an example. Okay. Okay, this is all about your divergence. The question will come from these type of varieties, two types of varieties. Whether the question will ask you find the divergence in different coordinate systems. Basically, it asks most of the time in JAM and other BSc level exams. It also asks you if f is solenoidal, find the value of a, find the value of x, find the value of y, like this type of constant. It will ask you. And next type of question, if you have studied the Gauss divergence theorem, in there also we will use divergence. Okay. So for today, this is all about for this. Okay. We will discuss call in our next class. Okay. See you then. Thank you.